Hi, it's Carly McAvoy. Today I'm talking about division properties for exponents. When we have the same base in the numerator and denominator, we can simplify the expression by subtracting the exponents. These are the examples I'm going to do in this video, and the last two we run into a little bit of complication, so stick around for those if you're having some that are a little more difficult. To start off with, here's an example where we have the same base x, and we can just subtract those exponents to find that answer. And when we subtract the exponents, we have 7 minus 5, or x equals x to the second power, And if you think about it this way, what we have here is we have 7 x's on top and we have 5 x's on the bottom. So if we were to go through and cancel everything we could cancel, there would be 2 additional x's on the top. So that's how we would get x squared. So it's kind of good to ask yourself, where do you have those extra x's? Okay, you can have more than one variable that you're working on at the same time, like example 2. And in example 2, what we want to think about this is 2 separate parts. You have a to the 10th minus a to the 1st. Because when we don't see an exponent like we don't here, we assume it's a 1. So it's a to the 10 minus 1, and then b to the 12 minus 9, and we have a to the 9th and b to the 3rd. Again, if you were to ask yourself, where do I have more exponents and how many more? You have more a's on the top by 9 and more b's on the top by 3. You could also have numbers as well as variables that you're working with here. That's not a problem. You want to think of that as 2 separate parts as well. So I would be thinking of this as 12 divided by 6. And then separately, I would be thinking about where do I have more n's and how many more. And you can see that 12 divided by 6 is going to be 2. And then we have more n's on top by 5. All right, in example 4, we can have numbers that come out to be fractions. That's perfectly fine as well. When I start this problem, I'm going to think of the 2 divided by 4 separately. I don't want to use decimals. I want to use fractions here. And then where do I have more v's? I have more v's on top. How many more? Well, it's going to be 3 more. So you could look at your answer this way. You have 1/2 here because 2 over 4 is 1/2, and then you have v to the 3rd, or you could write your v to the 3rd on top over 2. Either one of these are acceptable answers. Pretty much, I would say the second answer is how I would write it because it's just more efficient to write it that way. Example 5 is where we run into problems because we have, if you look at where the c's are, do we have more c's on top or more c's on the bottom? Well, we have more on the bottom. Up till now, they've all been more in the numerator. So what does that make us do? Well, when you look at this, I would be thinking about this as 15 over 35 needs to be simplified. I don't want a decimal, I just want to simplify that. And then I have c to the 1st, even though we don't see that exponent, we assume it's a 1, minus 7. And so what we get from that is reducing this, 5 goes into 15 3 times and into 35 7 times, and you can do that on your calculator. And then c to the negative 6. And we can't leave our answer with a negative power. Most of the time when you work these problems, it'll say give your answer with positive powers only. What does that look like as a positive power? Well, it doesn't jump into the numerator like it did up here. If it's a negative, it's going to jump into the denominator. And so we're going to have 3 over 7 c to the 6. Now we have 6 as a positive exponent, so that's good. We got rid of that. We'll look more about the negative rule in another video, but a better way to think of this when you're simplifying this is where do you have more c's and how many more do you have? And you can see here you have more c's in the denominator by 6, so it's going to end up in the denominator. That way you don't have to get to that negative and then move it. Just put it there straight out. So looking at this last one, this whole problem, I've got numbers, x, y's, and z, so I have all these factors. So I kind of think of these as 4 separate problems. The first thing I'm going to do is simplify 18 over 24. And so I can simplify 18 over 24 by dividing the top and the bottom both by 6. 6 goes into the numerator 3 times, and it goes into the denominator 4 times. So I have 3/4 for that part of it. The next thing I'm going to do is the x part. And I'm going to ask myself, where do I have more x's? And I can see that I have more x's in the denominator. So what I'm going to end up with x's in the denominator, 3 more. So we don't just leave a 0 on top. We put the 1 on the top, and then we'd have x to the 3rd power in our denominator. So that's what I have for the x's. then I'm going to ask myself, where do I have more y's? Now over here, y was just y, but I know that's y to the first. So in this case, I can see I have more y's on the top by 2, so I'm going to have y squared, or y squared over 1. You can write that either way, but the 1 isn't as important when it's in the denominator, but this is going to help us see where everything is. And finally, with the z's, where do I have more z's? I have more z's in the denominator. How many more? Well, 4 more. So again, when I write that, I don't want to leave the 1 off the top. I want to put the 1 in there. So I cancel all the z's out. That still leaves 1. And then z to the 4th power in the denominator. And now I want to take one more step and kind of write that all together. So in the numerator, what I have is 3y squared. Because I don't need to multiply by 1 and by 1, and again, it doesn't make any difference. In the denominator, I have 4x to the 3rd power, z to the, and z to the 4th power. And that's how I'm going to write my final answer, and by kind of thinking of them separately and then combining them up at the end. All right, have a fantastic day, and I'll see you next time.